Okay, and to round out this section, we're going to talk about finding an equation of a line that's parallel to another given line. And then next, we'll do the same thing, but finding a line that's perpendicular to it. First of all, the symbol for parallel is just these two vertical bars. Um, that just means two lines are never going to intersect. Okay. So finding an equation of a line parallel to a given line. So suppose you know the equation of line one is this line here, this equation. But you want to know the equation of a second line that goes through a different point that's not on line one. So here we've got line one, and here is a point that's not on line one. So we want to create a second line. It's maybe going to be somewhere out here that's going to be parallel to the first one and go through that particular point. So in order to figure out something like this, remember that parallel lines have equal slopes. Okay, so the slope of line one, we can see, is 2/3. So then that implies that the slope of our second line that we're trying to make will also be 2/3. All right, so we have that as a given. And we know that the second line is also going to go through the point 2, 3. So now this is already like an example that we've done where you come up with the equation of a line if you know the slope and a point. So this is our x and that's our y. So I'm going to use method one here. And so we need y equals mx plus b. And the y value is going to be 3. The slope is 2/3. And the value of x is 2. And now I need to find the y-intercept. So we're going to have 3 is equal to 4/3 plus b. And we're going to subtract 4/3 from both sides. All right. And let's see here. This is going to make things a little complicated. So we're going to make 3. We're going to convert 3 into 9/3, right? Because 9 divided by 3 is 3. And I want a denominator of 3 so I can subtract this fraction. So we're going to have 9/3 minus 4/3 is equal to b. And that'll give us 5/3 for a y-intercept. Okay, so here with y equals mx plus b, we know our slope is 2/3, and we just calculated the y-intercept to be 5/3. And 5/3 as a mixed fraction is going to be 1 2/3. And so if we come over here to our graph and we go up to 1 2/3, we can see that we're going to get a y-intercept right here. And if we rise 2 and go over 3, it's going to give us a point right there. So we can say with a quick sketch, we can see that this new line that we made is going to go through that point that we desired it to go through, just like that. All right, so that's how to come up with the equation of a line that's parallel to a given line. Now let's move on to the next page, and let's find the equation of a line that's perpendicular to another line. So I think this is the exact same equation. 2/3 minus 4. Yep. So we've got the same equation, the same line equation for line 1. And we wanted to go through the same point, 2, 3. That's what we had in the last example, 2, 3. But now the second line, we want it to be perpendicular to the first line, to line 1. So what we know, what we remember from perpendicular lines. So perpendicular lines have slopes that are negative reciprocals. Okay, that's what I've got right here. And so the slope of line 1 is 2/3. And so the slope of the line perpendicular to that is we're going to switch numerator and denominator, and then we're going to change the sign. So line 1, the slope was positive, so the perpendicular will have a negative slope. Okay, so the slope of the perpendicular line will be -3/2. And now we can just use one of our two methods. I'm going to use method 1 to get the y-intercept. And so here our slope is -3/2. The point that we are using is the 0.23. So we've got the 0.23. That is our x and y. Okay, so x is 2, y is 3. We're trying to solve for the y-intercept. So the 2's will cancel. And we have 3 equals -3 plus b. Add 3 to both sides. And the y-intercept is equal to 6. So the equation of the line is going to be y equals -3/2 x plus 6. And if we come up here and go through 6 on the y-intercept, and let's see, we can have, oh, -3/2. I said 3/5. So -3/2. I'm starting to see that something was wrong. All right, so with this slope of -3/2, again, we can think of that as a negative rise and a positive run. And so from this point, if we have a negative rise of -3, that goes down to there, and a positive run of 2, that puts us on our desired point. And if we go ahead and draw this line, we can see this line 2 is perpendicular to line 1. And the equation for line 2 is y equals -3/2 x 6. That looks right. All right. Let me know if you have any questions.